Welcome back. We're going over marathon now, and I think I've just covered half a kilometer. I still have 41.3 kilometers, something like that. And so I'm now in the 4th kilometer. At the moment, I have energy only. As you go to the last lap, then you go by more mental strength than your physical stamina. Okay. See, last lesson, I showed you how the question doesn't say use substitution, and you are expected to know how to use simple substitutions. Yeah? Let me take an example. I have integral 3x cube plus 4 power half, no, let's say power 5 times x squared dx. I will first show you the method of substitution which we did in the last lesson. This is not a standard formula, apart from the fact that if you want to expand everything and do it, God bless you. Whereas, when you differentiate 3x cubed plus 4, I get 9x squared, and I have an x squared, right? So I have a function and its derivative. So what's the method? Call the function as u. Some of you are wondering, sir, why are you doing the same thing? Because unless I show you this method, you may not understand the logic behind inspection. Please bear with me. I know it's a bit boring. You already clicked this, you're all genius. So there's no problem. It's 9x squared. So dx equal to du over 9x squared. So integral u power 5 x squared du over 9x squared. X squared cancels. 19 integral u power 5 du, which is 19 u power 6 over 6. So 1 over 54 times 3x cube plus 4 power 6 plus c. This was the method we did in the last lesson. Now for inspection, this is what I recognized. What did I recognize? That the derivative should be 9x squared. But what do I have here? X squared. What's missing? 9. Remember, you can use this shortcut or inspection only if and only if, I repeat, if and only if the derivative differs by a constant. Not again plus constant, minus constant. Differs by a multiplication of a constant or a division of a constant. So I need a 9x squared. So write it as 9x squared. Don't bother. This step must be shown. Show this step. You don't have to show that step, but you must show this step in the exam to get full marks. By writing that, you're telling the examiner, I am using inspection. Well done. Okay. But that was not the question. The question was only x squared. What did you do? 9x squared. You multiplied by 9, so divide by 9. So I'm still with the question. When you differentiate, this is the exact derivative of that. Then mentally, this is x power 5 and all of that is dx. Or u power 5 du mentally. T power 5 dt mentally. Donkey power 5 d donkey mentally. What does anything power 5 give you? Power 6 over 6. So this gives you 1/9 of 3x cubed plus 4 power 6 over 6, which is 1 over 54 3x cubed plus 4 power 6 plus 6. This is the same answer you got, but you didn't have to go through the whole lot. Alright? But this only works as long as the derivative differs by a constant. not otherwise. Okay, good. Let's take another example. So, to use inspection, identify the derivative. The derivative should differ from the question by only a constant. You can multiply or divide by a constant and then apply the formula directly. Let me take another example. Integral 3e power x squared minus 2x times, no, x squared minus, times, x squared minus 4x times x minus 2 dx. Okay, let's make it x squared plus 4x plus 2. Happy? So what you do is, it resembles e power. If it was only e power, I could integrate it. I have an x squared plus 4x. Let me use the substitution first. When you differentiate x squared plus 4x, I get 2x plus 4, which is 2 times x plus 2. So I have a function and its derivative. So standard method, u is x squared plus 4x. So du by dx is 2 times x plus 2. So dx equal to du over 2 times x plus 2. So integral 3 e power u x plus 2 dx is du over 2 times x plus 2. The x plus 2's cancel. It is 3 over 2 integral e power u du, which is 3 over 2 e power u, which is 3 over 2 e power x squared plus 4x plus c. That's the method of substitution. You're doing the same thing, but you're doing it mentally. When you look at the question, I have x plus 2, I need 2 times x plus 2. Take the 3 out, write the 2 times x plus 2, doesn't matter. But the question didn't have a 2, you multiplied by a 2, so divide by a 2. Please don't say, if there was only, let's say for example, I had integral e power 3x squared dx. When you differentiate 3x squared, you get 6x, yeah? So you say integral e power 3x squared times 6x dx, so 1 over 6x. That would be rubbish because you are dividing by a variable, the variable could be 0. Yeah? So therefore, you can only multiply or divide by a constant, not a variable. Please don't forget that. So that would be rubbish. Now mentally imagine this is t, the whole thing will be dt. Mentally you are integrating e power t dt. What does e power t give you? E power t. So e power x squared plus 4x gives you e power x squared plus 4x, 3 over 2 plus c. In other words, the method of substitution is the same as method of substitution, but with a bit of a difference. When you are doing my inspection, but in the exam, you need to show this step. By showing that step, you are telling the examiner, look, because from here if you write it directly, I don't know how you did it. Yeah? So show that step to indicate to the examiner, look, I am using inspection. I'll take 1 or 2 more examples, don't worry. Now this time, I will not show you the substitution method, I'll just do it directly. Suppose I had integral sec cube 2x sec cube half x tan half x. When I differentiate sec, the more complicated one is sec cube. Yeah? So when you differentiate sec, I get sec tan. I don't have a sec, but I have a tan. But sec cube can be split as, so can I write this as sec squared half x times sec half x tan half x. Right? You understand that so far? Because when the more complicated is a sec, when you differentiate a sec, you get sec tan. Don't go back to the formula above. Look at this. When you integrate sec tan, you get sec. So when you differentiate sec, you get sec tan. Yeah? What do you get when you differentiate sec half x? I get sec half x, tan half x, and a half. So write that. So d by dx of sec half x is sec half x times tan half x times half. What's missing here? A half. So write it as integral sec squared half x times a half sec half x tan half x dx. Okay? If this is u, the whole thing will be du. But the question did not have a half. I brought a half, so multiply by a 2. So this is a 2u square du. What does u square give you? U cube over 3. So what does x square give you? Not 10. Something squared gives you something power 3 over 3. So this is 2 sec cube half x over 3 plus. Of course, this is a bit confusing. If I were doing normal substitution, I would say u equal to sec half x. So dx is equal to 2 du. So I would get 2u cube du. And then I would 2u squared du, I would get 2u cube over 3. Same answer. Alright? Let's take one more example. Integral 3x minus 2 over 6x squared minus 12x plus 5 power 1/3. No. 3x minus 2. So 12, 4, 3x minus 2, 12x, 24x. Okay. No. 12, so 3 4s are 12, 4 2s are 8x. Okay. Alright. Now, substitution. What do you get when you differentiate? See, whether you use inspection or substitution, you have to differentiate the most complicated function. Is 12x minus 8, which is 4 times 3x minus 2, and the question has a 3x minus 2. Yeah. So you can say u equal to that, then find du by dx, and then make dx the subject and the method of substitution. Here, I'll write it as 6x squared minus 8x plus 5 power 1/3 times 3x minus 2 dx. But for it to be exact, I need a 4. So 4 and a quarter. So in other words, you make sure the dx has with it the exact derivative of the extra function. Yeah. Or if you don't like it, you can do u equal to 6x squared minus 8x plus 5 and use the method of substitution, you'll get the same answer. So it's quarter, anything power 1/3 gives you the same thing, power 2/3 over 2 over 3. So that is 3 over 8 times 6x squared minus 8x plus 5 power 2/3 plus c. I will leave it to you for practice. Do du by dx. But as I told you, be careful. Even though it saves you a lot of work, it requires a lot of thinking. If you're not comfortable, or if you're like me, committing silly errors, I would rather you use substitution. But if you wish to, you could use the method of inspection. But this you use only when substitution is not given. Either using your own substitution or using inspection is only when the substitution is not given. But there are some complicated questions where substitution will be given. That I will take it up in the next lesson. Okay? Have a nice day. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.